Hello everyone, here is day 28 LeetCode May challenge problem, counting bits. Let's look over the problem. So the problem says is that we are given a non-negative integer num, and for every I in range 0 to num, we need to calculate the number of ones in their binary representation and return them as an array. Let's look at it in more detail. So here is the problem statement, and the problem says that if we are having num, let's say 4, so we need to see their binary representation, and for every binary representation we need to calculate how many ones are there. For example, in 0 there are 0 ones, in 1 there are 1 1, in this 2 there is 1, in 3 there are 2 ones, and in 4 there are 1 1. So we will return this as an array. You can find the problem description link given below. Okay, so let's look what our approach can be. So I take num as 7, and initially for your reference I write their binary representation a number of ones. Okay, now the approach is very simple. I just start from 2 till num and write every number starting from 2 in the representation such that the divisor is 2. So I calculate the remainder and quotient. I can write 2 as 2 into 1 plus 0, like quotient is 1 and remainder is 0. 3 as 2 into 1 plus 1. Similarly 4 as 2 into 2 plus 0. 5 as 2 into 2 plus 1. 6 as 2 into 2 plus 2. And 7 as 2 into 3 plus 1. So I write the quotient and remainder for every number starting from 2 till that number. Now when I will write ANS, so initially for 0 and 1 I need to keep in mind these two values, that for 0 the number of ones is 0 and for 1 the number of 1 is 1. Okay, now for this one 2, I will see what the quotient and remainder is. So quotient is 1 and remainder is 0. So I will just pick up the value of number of ones at 1 and 0 position. So for number 1, number of ones is 1, and for number 0, number of ones is 0. So 1 plus 0 is 1. So for 2 I am getting 1. For 3 the quotient is 1 and remainder is 1. So I will look for number 1 position. Number of ones is 1. So I need to add it 2 times because quotient is also 1 and remainder is also 1. So I get 2. So yes, number of ones in 3 is 2. For 4, the quotient is 2 and remainder is 0. So for 2, the number of ones is 1, and for 0, it's 0. So 1 plus 0 is 1. So 4, I get it 1. For 5, the quotient is 2 and remainder is 1. So for 5, quotient is 2 and remainder is 1. So 1 and 1, 2. So I get for 5 as 2. For 6, quotient is 2 and remainder is 2. So for 6, the quotient is 2 and remainder is 2. So I add this 1 2 times. So I get 2, which is same. And for 7, the quotient is 3 and remainder is 1. So 3 and 1. So 2 plus 1 is 3. So I hope it's clear. It's a very easy approach. There can be many approaches, but this is one of my approach, and the space complexity is as well on, and it's linear time. Okay, so I just keep in dictionary these two things, 0 and 1, and for I in range, if I is in dictionary, I simply append the value in ANS, and otherwise I calculate the quotient and remainder and just feed that quotient and remainder value in my ANS thing. So pretty much I get the answer. Comment below the space complexity and time complexity. Also suggest if any other method for the same approach. And thank you for watching the video. Don't forget to like and subscribe.